Hi, welcome and thank you for joining me once again. Today we're going to talk about solving quadratics using factoring. So far we've been doing a lot of factoring of quadratics. Now we're just going to take that one little step further and we're going to actually find what we call a solution to a quadratic equation. So first of all, to kind of get the understanding of that, we're going to talk about the zero product property. The zero product property says that if we have two numbers that are multiplied together that equal zero, one of them has to be zero. So if a times b equals zero, then either a equals zero or b equals zero. In order to get an answer of zero when you're multiplying two things, one of the things you're multiplying has to be zero. There's just no other way to get zero for an answer. So for our first example, we're just going to start out real easy. This one's already factored for us. So we're going to solve n minus 8 times n plus 6 equals 0. So we're going to apply the zero product property to that. So what this is telling us is since we have these two things multiplied together that equal 0, either a is 0 or b is 0. So that's this one. This would be a, this would be b. So setting each one of those equal to 0, n minus 8 equals 0. So just solve, add 8 to both sides. We get n equals 6. Or if n plus 6 equals 0, we subtract 6 from both sides, and we get n equals negative 6. So you can hopefully tell once they're factored and you set each one equal to 0, finding the solution from there is just one little step beyond what we've already been doing. Okay, so let's go to some examples where we actually have to factor. So remember, a real number solution to a quadratic equation occurs where y equals 0. So we're not going to have a y in a lot of these that we're practicing with, but just keep in mind that if we had y in there, when we're finding the solution, we would take out the y and we would substitute 0 in its place. So really we are finding the solutions of that graph of y equals whatever that quadratic is, and we're finding those x-intercepts. That's really what we're doing here. Okay, so that's a very important connection to make here. So really we're looking for where the graph crosses the x-axis, and to do that, y has to be equal to 0. So in each one of these examples, some of them, this one is already equal to 0, but in the next few, some of them won't be equal to 0 already. So what we're going to have to do is just move everything to one side and set it equal to 0. Okay, so we're going to start out with an example hopefully we're familiar with. We're going to see one that's the difference of two squares. So example A, 4x squared minus 25 equals 0. Well, hopefully you notice this is a perfect square, this is a perfect square. So if you remember that pattern of the difference of two squares from before, you hopefully recognize this factors into 2x plus 5 times 2x minus 5. Just find the square root of this is 2x, the square root of this is 5, and we use that pattern of a plus b times a minus b. So here is that pattern. And again, since this one's equal to 0, we're going to take each piece, the 2x plus 5 and the 2x minus 5, and set them equal to 0. So when we do that, so here to solve this one, we're going to subtract 5 from each side and then divide by 2, and we get x equals negative 5 halves. And here we're going to add 5 to each side and divide by 2, so we get x equals positive 5 halves. So negative 5 halves, positive 5 halves. We could rewrite this as x equals plus or minus 5 halves, for example. Okay? So moving on. Example 2b, we're going to solve this. m squared plus 9m plus 8 equals 0. So remember when we're factoring, we kind of have to think about what are two factors of this that add up to this. So factors of 8 could be 2 and 4 or 1 and 8. Well, in this case, 1 plus 8 does equal 9, so we know our two factors must be 8 and 1 that add up to 9. And the m squared, of course, is going to factor into m times m. So if we were to refoil this back out, and you could certainly check any of these examples that we're doing by refoiling them back out, but m squared plus 1m plus another 8m gives us 9m plus 8, and that's equal to 0. So we're going to set each factor separately equal to 0. So m plus 8 equals 0, or m plus 1 equals 0. And now solve each one separately. So subtract 8 here, we get m equals negative 8, or subtracting 1 here, we get m equals negative 1. Now, if we plug negative 8 and 1 back into this original equation, it should work out that this side equals 0. And I'm just going to do one of them. If you want to look at the other one and check, you certainly can. But negative 8 squared is 64, plus 9 times negative 8 is negative 72, plus 8. That's just what we had here with negative 8 substituted in for m. And when we evaluate that, we get 0 equals 0. So it does work out. Okay, next one. So remember this one, it isn't already set equal to 0. We have n squared plus 15m plus 47 equals negative 7. So just like I said before, we always want to set it equal to 0 first. So to do that, we just need to add 7 to both sides, and now we have 0 left over here. Okay, so first set equal to 0. Now we're going to factor. So we have n squared plus 15n plus 54. So thinking about 54, two ways that we can factor 54, or a way we can factor 54 into two numbers, I should say, that equals positive 15. So 54 could be 2 times 27, but that's not going to work. Maybe 3 times something, but that's not going to work. But hopefully you see 9 times 6 is 54. 9 times 6 is 54, and 9 plus 6 does equal 15. So that's the one that's going to work, is the 9 and the 6. So this is going to factor to n plus 9 times n plus 6 equals 0. So now, once again, set each one equal to 0 and solve. So n plus 9 equals 0, subtracting 9 from both sides, we get n equals negative 9. Or n plus 6 equals 0, subtract 6 from both sides, we get n equals negative 6. Okay, and again, I'm just going to go through the first check, but you can certainly check both of them. If we put in negative 9 for n, negative 9 squared is 81, plus 15 times negative 9. Well, 15 times negative 9 is 135. And then plus 47 up here should equal negative 7. Okay, so 81 minus 135 is negative 54. Negative 54 plus 47 is negative 7. So we do end up with negative 7 equals negative 7, and it's good. It actually did work back in the original equation, so we know that we found the correct answer once again. And remember, anytime you solve any of these, you can always check your answer by plugging those numbers back into the original equation and see if it works. So if you're taking a test and you want to know that you got it right, check your answer. Just plug it back in real quick. You can even use your calculator to do so. Plug it back in, check and make sure that it works out. Okay? So moving on. Just a couple other examples here. So solve one more. We're just going to do another simple example like this. Solve x squared equals x plus 2. So remember, we want to set equal to 0 and factor. So we just need to move all of this over to the other side. So subtract x, subtract 2, we end up with x squared minus x minus 2 equals 0. And now we can factor. So two factors of negative 2 that add up to negative 1. Well, that's pretty easy. Negative 2 and positive 1 works. And so if we take each one once again, set equal to 0, x minus 2 equals 0, or x plus 1 equals 0. So x would equal positive 2, or x equals negative 1. You can check both of those, and I've done that check over here for you, but it does work once again. And what I did is I put, for example, 2 into the original equation. 2 squared is equal to 2 plus 2. 2 squared is 4. 2 plus 2 is 4, so it works. Okay. Last example, I saved the hardest one for last. So set equal to 0 and factor. So we have 7a squared plus 14a plus 1 equals negative 7a squared plus 5a. Now here's where some of you need to be careful. 7a squared here and negative 7a squared here don't make 0, because we do have to add 7a squared to both sides. 7a squared plus 7a squared is equal to 14a squared. So be careful with your manipulating of your equations. And then if we move the plus 5a over to the other side, we do the opposite and subtract. So minus 5a, 14a minus 5a is 9a. So 14a squared plus 9a plus 1. Okay, 14 is 7 times 2, and 7 plus 2 is 9. So I know that that particular way will work. The other way would have been 14 times 1, but 14 plus 1 is 15. That doesn't work. Okay, so here is where this time I use factoring by grouping. So just a reminder on factoring by grouping, I took the 9a and split it up into 7a plus 2a, and then I grouped these two together and these two together, and now I'm going to factor out what's common to both terms for each set of parentheses. So here what we have common is 7a. So I bring the 7a out front, and if I factor 7a out of here, we have 2a left over, and if I take 7a out of here, we just have plus 1. So 7a times the quantity 2a plus 1. Here we already have 2a plus 1, so really all that's common in there is 1. Okay, so now I'm going to factor, since both of these terms have a factor of 2a plus 1, I'm going to factor that out front. 2a plus 1, what's left over is the 7a plus 1. So 2a plus 1 times 7a plus 1 equals 0. Okay, so we still have to solve from here. So set each one separately equal to 0. 2a plus 1 equals 0, or 7a plus 1 equals 0. So I'm going to solve this side. Subtract 1 from both sides. We get 2a equals negative 1. Divide both sides by negative 2. We get a equals negative 1/2. And on the other side, 7a plus 1. We subtract 1 once again. 7a equals negative 1. Divide both sides by 7. A is equal to negative 1/7. Now, this one's probably a little more complicated to check. We could certainly put both of these back into the original equations and check. The numbers will get a little messy because they're fractions and we're squaring them and all sorts of stuff. The check may not be quite as nice, but if you want to check, you certainly could use a calculator to just put in, just substitute negative 1/2 in for the x. Remember to put a set of parentheses around the negative 1/2 before you square it on both of these, and same with the negative 1/7. Put that in parentheses before you square it. But otherwise, you can certainly use a calculator to check this. Okay, well, that's all there is. So just, again, all we're doing is we're taking the factoring that we've been doing, one extra little step, setting the factors equal to 0, and solving from there. So hopefully this isn't too much more on your plate than what you've already been working with. Should be a fairly simple one little extra step to move on. So thank you once again for joining me. Have a great day, and I'll see you again soon.